Hello everyone, myself Shriddhi Shukla, volunteer at Shivi Forensics, and today I will be speaking on an exciting and important topic forensic toxicology, detecting poisons in criminal investigations. Why this topic? Because poisons have always been a silent weapon of crime from ancient times to modern cases. Forensic toxicology is the science that unmasks these silent killers and give a voice to victims who cannot speak for themselves. Let's begin our journey into this fascinating field. What is forensic toxicology? To understand forensic toxicology, let's break the term. Toxicology means the science of poisons, whereas forensic means applying that science to law and justice. So, forensic toxicology is about detecting and identifying poisons, drugs, and other toxic substances in biological samples such as blood, urine, or tissues to reveal their role in death, accident, or crime. To appreciate today's toxicology, let's look at its root in history. Poisons are as old as human history. First is Paracelsus, the father of toxicology, who gave us the famous principle the dose makes the poison. Even water can be toxic if taken in extreme amount. Next is Matthew Orfila, who is considered as the founder of modern toxicology. He scientifically studied poisons and wrote the first textbook on toxicology. Next is James Marsh, who developed the Mars test, which for the first time allowed accurate detection of arsenic, a favorite poison of 19th century. Some famous poisonings include the philosopher Socrates, executed by Hemlock. Next is Napoleon Bonaparte, who is suspected to have been slowly poisoned by arsenic. These cases remind us that poisons are powerful, but what are the most common ones used today? Some common poisons and toxic found in modern investigations are pharmaceuticals, illicit drugs, household and industrial chemicals, natural toxins. Pharmaceutical drugs are the medicine that can be deadly if misused. Example, opioids, sedatives, and antidepressants. Next is illicit drugs, cocaine, amphetamines, cannabis, and even synthetic party drugs. Household and industrial chemicals are pesticides, carbon monoxides, or cleaning agents, often involved in accident or suicidal poisoning. Some natural toxins are resin from castor beans, oleander plant toxins, snake venom, and bacterial toxins. Now that we know the poisons, let's see how they actually enter the human. Poisons can silently enter the body in four main ways: ingestion, inhalation, injection, absorption. Ingestion, swallowing contaminated food or drink. Inhalation, breathing in gases such as carbon monoxide or cyanide. Injection through syringe, animal bites, or even exotic cases like ricin pellets. Absorption through skin contact like pesticides or drug patches. Each route leaves different traces for a toxicologist to detect. But poisons alone don't solve the mystery. The toxicologist's role is central to uncovering the truth. A forensic toxicologist wears many hats. First, at the crime scene, guiding investigators on proper collection of evidence. Next is in the laboratory, analyzing biological samples with precision. In interpretation, translating scientific data into simple findings. And in the courtroom, presenting evidence and an expert witness. In short, the toxicologist connect the dots between science and justice. But before testing, evidence must be carefully collected and protected. The reliability of toxicology depends on the integrity of samples. This involves collection using sterile tools and protective gear, packaging in secure, sealed, and clearly labeled containers, storage under proper conditions, often refrigeration, documentation of every person who handled the sample, ensuring an unbroken chain of custody. If chain is broken, the evidence can be rejected in court. Once samples are safe, how do toxicologists actually detect these hidden poisons? There are some analytical methods. or technologies help toxicologists detect even microscopic traces of toxins. First is gas chromatography, liquid chromatography, immunoassays, and atomic absorptions. Gas chromatography, mass spectrometry, separates and identifies volatile compounds like alcohol or solvents. Liquid chromatography, mass spectrometry, ideal for complex drugs or unstable compounds. Immunoassays, it is used for screening, tests for drug classes in using antibody reaction. Atomic absorption or emission spectrometry, which detects heavy metals such as lead, mercury, or arsenic. These methods ensure precision, accuracy, and reliability in toxicology reports. So, what does all this mean in the big picture of justice? Forensic toxicology is cornerstone of criminal investigations. It reveals the presence and effects of poison, bridging chemistry, medicine, and law. Toxicologists solve cases of homicide, suicide, accidental poisoning, and drug abuse. Ultimately, their work ensures that science supports justice and that no crime remains hidden behind the silence of a poison. With that, I would like to wrap up my presentation. Thank you for your time and attention. It was my honor to share with you how forensic toxicology helps detect poisons and deliver justice.